Okay, in this video I want to go over the induction by confirmation just quickly. And so right now I'm looking at the first reading that you had in Introduction to Arguments. So you need to have this, and it's the first reading in the course pack. So on page 16, the bottom begins the section on the induction by confirmation. I'm not going to read it to you, but you of course should read it yourself. I just want to point out a couple of things. So in this argument, we have this type of argument. We have a hypothesis, and here's the definition of a hypothesis, a proposed explanation for something that can't be observed. The other important part of the induction by confirmation is the prediction. Okay, and there's an example of how that works here, which I'll let you look at. And then if we have the argument itself, this is the format or the template for this type of argument. Down here is an example. So the first premise, or really it can be either premise, but typically it's going to be the first one, is a conditional statement. Recall that a conditional statement is defined back here on page 11 under the modus ponens. So a conditional statement has the form if A, then B. And the first clause, the A clause, is called the antecedent, and the second clause is called the consequent. Okay, so back to where we were. So in the induction by confirmation, the hypothesis goes in the antecedent of the conditional statement, and the prediction, what we expect to see if the hypothesis is correct, is the consequent, the second part of the conditional statement. Then, of course, it may or may not be that what we predicted that we would find, or that what whomever predicted that he or she would find, is what they find. But when it is, then in premise 2, we can say whatever we expected is what we found. And then, so if we do find what we were expecting to find, then that confirms to some degree the hypothesis. So then our conclusion can be the hypothesis is probably true. Okay, this kind of argument is always going to be invalid. It can be inductively strong, might not be inductively strong, but it can't be valid. All right, now, okay, now here's an example. Okay, now next, I want to go over 2 examples of arguments, and type these out. My tablet is charging. Okay, so the first one. All right, if today is Monday, then you have English Lit. So again, we start with a conditional statement. This is the antecedent. This is the consequent. Okay, but this time we have as our second premise, or the other premise, is the antecedent of the conditional statement. Put that here. Okay, and then the conclusion is the consequent of the conditional statement. You have English Lit. All right, so this is not an induction by confirmation. This is modus ponens. Where was that? Okay, back here on page 12. Okay, so any argument that has this form, if A, then B, then the other premise is A, the antecedent, and the conclusion is therefore B is modus ponens, and it's always valid. Basically, this is saying if this first thing happens, then the second thing has to happen. The first thing did happen, so following by the conditional statement, the second thing has to happen. If these 2 premises are true, then this conclusion has to be true. So it's modus ponens, and it's always valid. Okay, now the other thing I want to point out, or actually the main thing I want to point out about this argument, is that it's fine, but it's very limiting. Presumably you know what your schedule is on Monday, you know what classes you have, and then you find out that it's Monday, then you can draw the conclusion that you have English Lit or whatever class it might be. So that's good, but this kind of argument is not going to give you any new or interesting information. To do that, we have to turn to the induction by confirmation or one of our other arguments that is not deductively valid. But we'll just focus on the induction by confirmation right now. So let's consider this argument. Okay, so here we have an induction by confirmation. It's always invalid, but it can be inductively strong. And so if it's inductively strong, then that means if these premises are true, then the conclusion, then they make it likely or very likely that the conclusion is true. Okay, so, all right, so look at the premises. If Sam likes you, then Sam will text you every day or almost every day. Sam does text you every day or almost every day. So based on those premises, it's reasonable to draw the conclusion that Sam likes you. Here I'm assuming Sam is the kind of person who would like you. He or she is not your mother or your father or trying to collect money from you or whatever. So all that being said, the argument is, I would say, inductively strong. Okay, so then here, Sam likes you. That's our hypothesis. Now, the situation then, of course, is you don't know. Sam hasn't said, I like you, and it's not probably reasonable to expect that Sam is going to say, I like you right from day one. Hopefully he or she will at some point, but you've got to figure it out before then. So you form the hypothesis. Based on that hypothesis, you form a prediction. Sam will text you almost every day. If Sam does that, then we have what we have in premise 2. What we expected to find is what happened. So then we can draw the conclusion that the hypothesis is probably true. Okay, so it's not the most serious example. Galileo's induction by confirmation is more consequential, but this is a case where you're not necessarily going to have Sam produce the information for you, and so you need to figure it out with this kind of inference. All right, I'll leave it there. Do the reading. I'll see you on the internet.